Hello, we're taking a look at exponential functions, specifically taking derivatives and integrating exponential functions. And for my class, this is the notes on section 5.4 out of our textbook. And so we have this relationship, and specifically the one we're going to take a look at is f of x equals e to the x. Well, if I take the derivative of that, what's nice about e to the x is its derivative is e to the x. So if I have something in this form, where f of x is equal to e to some power, and my power in this case is some type of function, its derivative, according to the chain rule, is going to be e g of x, so that exponential function doesn't change, but it does get multiplied by the derivative of g, or g prime of x. So let's take a look at some examples. The first example I have is, and I'll call it A, and this is under heading number 1 in the notes, is f of x equals e to the 2x minus 1 power. Well, its derivative is going to be that function, which is e to the 2x minus 1 times the derivative of this function up here, which is 2. So my final answer is 2e to the 2x minus 1 power. B, I have f of x, and it looks like this in the notes. F of x equals e to a negative 3 over x. And I'm going to rewrite that. So I have f of x is equal to e to the negative 3x to the negative 1. That derivative is going to be the same function, e to the negative 3x minus 1, times the derivative of the function, which is going to be 3x to the negative 2 power. So I'm just going to simplify this and write this as 3e to the negative 3 over x, that's what x to the negative 1 means, over x squared. Someone also could write it as 3 over, since this is a negative exponent, as 3x squared e to the 3 over x power. Alright? C is f of x equals e to the x minus e to the negative x over 2. And this can be rewritten as 1/2 e to the x minus 1/2 e to the negative x, and the derivative is going to be 1/2 e to the x, that the derivative of this is simply itself, plus 1/2 e to the negative x. The derivative of this is a negative 1, and I took this negative 1/2 times that negative 1, and it became a positive 1/2. I can rewrite that in this form if I chose to, where everything's over 2 and it's e to the x plus e to the negative x. Alrighty. The next thing I'm going to take a look at is, from taking derivatives, I'm going to take a look at doing antiderivatives. So I'm going to clear my screen and I'm going to look at this type of problem. I know that when I integrate e to the x dx, I get itself plus c. So if I have something like this, where I have e to the g of x, I'm going to need, according to the chain rule, inside here, the derivative of g. I'm going to need that. And again, what I would get here is e to the g of x plus c. Alright, so we're going to take a look at some problems like that. And here's example 2. And I have the integration of e to the 3x plus 1 dx. So what I'm going to do is I'm going to let u equal 3x plus 1. That means du dx is equal to 3. That means 1/3 du is equal to dx. Okay, I multiplied both sides by dx and then multiplied both sides by 1/3. That means where I see this dx, I can replace it with this 1/3 du. And it's going to look like this, 1/3, integrate. Here's my du. That's my dx. They're right here. And then I'm going to have e, and this is going to be replaced by a u in the exponent. So when I take the derivative of this, I'm simply going to have 1/3 e to the u plus c. And then I can substitute the u and replace it with 3x plus 1. And then again, I have my constant that I'm adding. All right, let's look at example 3. And it is, excuse me, integrating 5x e to the negative x squared dx. I'm going to let u equal a negative x squared, because I know the derivative of this is a negative 2x, so at least I have the x, but I don't have the negative 2, and so I'm going to show you how we get that. Du dx is equal to a negative 2x, so I'm going to have a negative 1/2 du is equal to x dx. Now, I'm going to multiply both sides by 5. And so now I have this 5 dx that I can substitute a negative 5/2 du in for. So it's going to look like this, a negative 5/2, integrate. Here's my du. My e, and u replaces a negative x squared. And so when I take the derivative, I'm going to have a negative 5/2 e to the u plus c. Well, what's u? U is a negative x squared plus c. Number 4 is a rational expression. Here I have x squared, and here I have e to the 1/2, 1 over x dx. And what I'm going to do, I think this is a difficult one to see unless you change it so you can see the exponents a little bit better. So I'm going to have x to the negative 2 here, and I'm going to have e to x to the negative 1 power dx. And I can see when I take the derivative of this, I'm going to get x to the negative 2 power. So I'm going to substitute u in for x to the negative 1 power. That means du dx is going to be negative x to the negative 2 power. That means a negative du is going to equal x to the negative 2 dx. So this negative du is going to be replacing these two terms. So I'm going to have the negative sign from the negative du. Here's my du. Here's e to the u power. So I'm going to have a negative e to the u plus c, and now I'm going to resubstitute my x to the negative 1 power in for u plus c. And another way you may see this is a negative e 1 over x plus c. It's the same type of thing. Alrighty, I'm going to clear the screen one more time. And I'm going to look at this particular example. In this particular example, example number 5. And it's a definite integral, and it's going from 0 to 1. So a is 0, b is 1, of e to the x to the 1 plus e to the x. Now this is a little different from previous ones. And if I put parentheses around here and raise it to the first power, I can see that the derivative of 1 plus e to the x is e to the x. The derivative of 1 is 0. So I'm thinking I'm going to involve the natural log because I have this exponent of 1 in the denominator. So I'm going to let 1 plus e to the x equal u. That means e to the x is equal to du dx, which means that e to the x dx is going to be du, which is right here. So this portion right here is going to be du. And when I substitute, I drop the a and the b because these are x terms. And I can figure out what they are by substituting 0 in for x and 1 in for y up here. But I'll just do the substitution at the end. So I have 1 over u du, which means I have the ln of u, which is equal to, or implies, I should probably say, implies the ln of 1 plus e to the x evaluated from 0 to 1. So that gives me the natural log of 1 plus e to the first minus the natural log of 1 plus e to the 0, which gives me the natural log of 1 plus e minus the natural log. This is 1, so I'm going to end up getting 2. And this can be rewritten as the natural log of 1 plus e over 2. Alright, so you could go and plug this into your calculator and see what decimal representation you have. And you should find out that those are equivalent.